Mike Brown, a Kuiper Belt expert and astronomer, once said the Kuiper Belt is an icy region at the outermost edge of the solar system that contains a deep frozen record of the early history of our solar system. NASA has revealed new shocking details about what is really hidden in this mysterious and little explored zone. We need to be ready for a lot because the latest findings could prove that the history of our solar system was very different from what we thought. Strange objects in a previously unknown planet could completely upend our worldview. Was it a big mistake that we paid so little attention to this region for so long? The Kuiper Belt begins about 4.5 billion kilometers from the Sun and extends up to 7.5 billion kilometers from the Sun. As a result, it forms the outermost edge zone of the solar system, and we have only discovered and explored a fraction of its astronomical treasures and peculiarities. Frequently, items that worry scientists due to their mass and width show themselves here. Up to 20 times larger and 2,100 times more massive than the main asteroid belt between Mars and Jupiter, the Kuiper Belt is a vast region of ice rock and frozen gases. Another strange occurrence in the Kuiper Belt region is the so-called scattered discrepancy, a zone of irregularly distributed celestial bodies that even stretches well beyond the belt's regular boundaries. The light conditions in the Kuiper Belt are very poor, and because the area is so far from the Sun, the few rays of sunlight that do reach these far-off objects only produce a pale light. In addition to being exceptionally cold, the Kuiper Belt is also very difficult to explore because there is hardly any light to break through the icy darkness. This extremely cold environment is ideal for perfectly preserving all of the primordial materials from which the bodies there have formed. The Kuiper Belt is a region of darkness and cold, but it is also a dynamic zone that contains many dwarf planets like Pluto, Eris-Ha, and Makemake. These objects provide unique insights into the physical conditions and chemical composition of the early solar nebulae from which our solar system was formed. In addition to the dwarf planets, there are countless other objects, such as comets and smaller icy bodies, that may contain important organic compounds relevant to understanding the chemistry of life. To date, probes have only visited and explored this remote area twice. Following the first thorough examination of Pluto and its moon Charon, Pioneer 10 conducted its first flyby in 1983, but did not come across any particular Kuiper Belt objects. In 2015, New Horizons ventured farther into the Kuiper Belt and made a number of discoveries. Ultima Thule, commonly referred to as the strangest object in the solar system, is so distorted that it defies certain physical laws. A time capsule of immeasurable value. Would you have believed that asteroids and comets are original remnants of the early solar system when the Sun was still forming in an extremely hot and rapidly rotating dust disk, and other rocks and objects were already forming in the remaining primordial plasma? These objects have remained unchanged to this day in some parts of the solar system. Previous research has shown that asteroids and comets contain an astonishingly high degree of mineral and organic substances, such as magnesium sulfates, iron, copper, and even amino acids, which are also the building blocks of life. The soil on our planet, plants, our bodies, and much more. It is simply astounding that these substances were apparently present in high density in the early solar system. If we take the idea a step further and take into account the most recent discoveries in astronomy and cosmology, we cannot currently rule out the possibility that there were also fertile phases with life forms on other planets. We suspect organic life on some icy moons that are warm at depth and could support life. This does not depict a gradual emergence of living conditions within the solar system. Rather, it shows that life was intended from the beginning, and that it is perhaps even rather unusual that there is only one planet with organic life in our solar system. Liquid oceans in harbors. Because we know so little about the past, we cannot rule out a fertile period with life on Venus, and computer simulations have also suggested that Mars may have once had an atmosphere and liquid water. Scientists are very interested in witnesses like objects that haven't changed since the solar system's inception. Research into the Kuiper Belt has only recently started. Welcome to the trans-Neptunian zone. It's well known that around 2,000 new, small planets have been found in the Kuiper Belt. These are known as trans-Neptunian objects. Pluto is the largest of these planets, and because of this, it had to give up its planetary status in 2006. Since then, Pluto has been officially classified as a dwarf planet and goes by the unattractive catalogue number 134340. The astronomer Clyde Tombaugh discovered Pluto in 1930, and people were very happy about it at the time. After Pluto, no additional planets were found until 2005, and it wasn't until then that ours showed up in front of the researchers' telescopes. The 1990s saw the start of the Kuiper Belt's exploration, but it took another 2 years before it was evident how large and what kind of belt it was between Mars and Jupiter. The asteroid belt, in which around 1.9 million objects are bound, the asteroid belt was discovered because researchers suspected another planet there, instead of a planet over one. 9 million individual objects then appeared, which at times were thought to be fragments of a shattered ninth planet. However, such assumptions have not yet been confirmed. In fact, researchers have also been searching for another planet in the Kuiper Belt for several decades, the 10th at the time, and now the 9th after. The degradation of Pluto. Some astronomers are of the opinion that there must be another larger body behind Neptune, somewhat larger than our Earth, and a little smaller than Neptune. So far, the legendary Planet 9 has not been clearly confirmed, and research into whether it really exists or not is still ongoing. The reason for this assumption is the orbital anomalies of some smaller planets in the Kuiper Belt, which can best and most coherently be explained by the existence of another planet. Certain irregularities in Neptune's orbit could also provide clues. It's amazing how researchers have been intensively studying our outer solar system for around 100 years. Since that era, we have had telescopes that allow a clear view of this dark area. But although the telescope's reach easily extends to the Kuiper Belt and beyond, it's the light that often thwarts researchers. For example, it is easier to study our nearest stellar neighbor, Alpha Centauri, with telescopes than the comparatively much closer Kuiper Belt. Researchers typically first notice invisible objects like planets, or even entire clusters of smaller objects, like those in the Kuiper Belt or the asteroid belt, because of the gravitational force they exert. They then estimate the approximate location of one or more other objects and begin a focused search for gravitational anomalies. Gerard Kuiper, who gave the region its name in the 1950s, believed that there was much more to be found. There are numerous unidentified objects in the scattered disk beyond Neptune, but very few people are aware of this other part of the solar system, which scientists call the scattered disk. The disk-like zone starts approximately at the outer edge of the Kuiper Belt and stretches several million kilometers farther out into space. Some of the objects in this region have orbits that take them up to 150 million kilometers away from the Sun because of this enormous extension. This intriguing and mysterious region of the solar system is partially connected to the Kuiper Belt, but also extends far beyond it in some places. Even less studied than the Kuiper Belt, the dispersed disk is one of the solar system's most remote areas. What is remarkable about the objects in the scattered disk is the high eccentricity and inclination of their orbits. These unusual orbits are likely the result of gravitational interactions, particularly with Neptune. As the large gas giants of our solar system took their places in the system, their powerful gravitational fields disturbed the orbits of many smaller icy objects. Those that were close enough to be affected by Neptune's gravity, but not ejected from the solar system, ended up in the scattered disk, which is likely a kind of comet reservoir. Some of these objects are periodically drawn to the Sun, and then occasionally enter the inner solar system. Comet Hale-Bopp is a well-known comet that is thought to originate from the scattered disk. Anyone who saw Hale-Bopp in 1997 witnessed a truly unique visit, because it is categorized as a long-period comet, whose orbit takes it far into the outer reaches of the solar system. Its orbit has a very high eccentricity, which is typical of comets that come from the dispersed disk. The object takes about 2,500 years to orbit the Sun. It is clear that our solar system has not always looked like it does today. It likely took millions of years for all the objects to fall into place, and for the orbits of the majority of the planets to become so stable that order prevailed in the system. Imagine what it must have been like when planets were still vying for position in the system, and many more asteroids and comets were hurtling through the system. At that time, collisions were even more frequent, and our Earth also experienced periods when comets were raining down from the sky. This makes the scattered disk particularly fascinating from a scientific standpoint, because it provides information about the dynamic processes that have shaped the outer solar system. It is still unknown where the initial impulse for the emergence of bacteria came from which ever more complex living beings later developed during the course of evolution. Some researchers even believe that this is how water and eventually life came to our planet. Comets are primarily composed of ice, and their organic components could make them truly heavy messengers of life. To ensure you never miss a new video, subscribe now.